Now in this problem, it's really a graph A we're going to look at and the graph B. And we don't have the equations, we just have the polynomial pictures of the graphs, and I want to state what the degree could be and then the combination of real and complex solutions that would be possible. If we look at this graph A here, we're going to clearly see that there are two unique x-intercepts right here and right here. So I know there's two zeros. If I do that horizontal line test here, and I'm going to notice it crosses 1, 2, 3 times, so there's at least a third degree polynomial. So I know this is at least a third degree polynomial. It could be more. It could be 5, 7, 9. It could have pairs of complex numbers that go together that I'm never going to see in here. Okay, here's the question though. I know it's at least a third degree. What makes up those three numbers? Well, I know there's at least two reals. So here, for sure, there's two reals. Now, to get to that third one, the question is, there's one more left. Could it be a pair of imaginaries? It can't be, because complex numbers or imaginary numbers travel in pairs. So the only next one I could have would be a fourth degree, but it's a third. What makes up that third one? Well, what I know is one of these zeros must have a multiplicity of 2. I don't know if it's this 0 with multiplicity 2 and this is multiplicity 1, or is it this one multiplicity of 2 and this multiplicity of 1. But I am guaranteed that all three have to be real in here. And I do know one of them has to have at least, has a multiplicity of 2. Now, that means I know there's three reals. Again, there could be pairs of imaginaries that would bring us to the 5th, the 7th, or the 9th. Let's look at graph B. Now, in graph B, if we look at how many x-intercepts we see, there's 1, 2, 3 unique reals for sure. If we do the line test on this one and cross it over, it crosses at 1, 2, 3, 4, 5. So this is at least a 5th degree polynomial. Again, I could have pairs of imaginaries, so it could go to 7, it could go to 9, it could go to 11. If there's three reals in this picture, that means there's two more that have to come from somewhere. So what combinations of reals and imaginaries could there be? Well, I could have two reals and there could be two complex. That could make up the 5 because complex travel in pairs, so that's possible. Now, if that's not the case, if I know they're reals, it could be this, or it could be that there's 5 reals. Now, if there's 5 reals, they have to be multiplicities somewhere. It could be that maybe this 0 has multiplicity of 2, this has multiplicity of 2, this has multiplicity of 1, making up my 5. Or maybe this one has 2, 2, and 1. Another possible combination is, what if this one had a multiplicity of 3? This was multiplicity of 1, multiplicity of 1. Or this had multiplicity of 3, this was 1, and this was 1. That could make up the 5 reals. There's lots of ways to make up the 5 reals, but I don't know if it's 5 reals or it could be 3 reals and 2 complex to get me to the 5.